All right. So when you see a problem like this, we've done this a bunch of times before, right? You hope that it's a certain type that you know. This is the one where the leading coefficient is not 1. It's 4, -6. You have to multiply 4 times -6, which is -24. Do you remember what we did from here? What the next kind of step is?
Gotta find something that multiplies to -24 but adds up to -5.
Yes, yes, very good. All right, and this could take a while, so I'll just help here because I don't want to use up our whole lesson here on this. But it is -8 and 3. And then you have to decide, well, which pair is better with 4x squared? Is it -8x or is it 3x?
-8x.
-8x plus 3x minus 6 equals 0. Very good. And then you're now finding the GCF of the first two terms, the number and the variable combination that goes into both.
$4x.
Okay, 4x comes out. And inside parentheses is x minus 2. And you write that over here as well. What goes in between them?
+3.
+3, good. All right. So here we go. You factor out x minus 2, and you're left with 4x plus 3. You set it equal to 0. And from here, do you remember what to do to solve?
Yes. We got x equals -3/4 and x equals 2.
Yes, perfect. Okay. All right, on to number 2. On to number 2. Now notice how number 1 was already set equal to 0. This one is not set equal to 0. So we should make it equal to 0. That should be our goal. The easiest way is to move this to the left. How do we do that?
Add +x squared to both sides.
Good. And the reason we choose to do that rather than move the terms the other way is you really want x squared to be positive. It can be negative, but it's better to make it positive. All right, so now kind of similar to the last one, you're looking now for two numbers that multiply to -48, but add to -13. This could be a tall order here. Are you allowed to use a calculator?
Yeah.
Okay, so the way you would do this, do you have a calculator handy?
Not at the moment. I gotta go get one.
Okay, could you quickly grab one? It doesn't have to be a big calculator. It can just be a, for function, but we want you to be able to do this if you
All
can.
right. I'll be back one second.
Okay. Do you have that calculator handy?
Okay, I have it now.
Okay, fantastic.
Uh,
So the reason I wanted you to grab that calculator is you want to go to that calculator and you want to start dividing by like 2, and then by 3, and then by 4, and then by 5, and then by 6, and so on. And you look for whole numbers like 2 and 24 work, 3 and 16 work, 4 and 12 work, and so on, right? But you still have to apply the signs. You have to apply which one's positive, which one's negative, which one's positive, which one negative. And you're looking for the one that's minus 13 apart or adds up to minus 13. Is it clear what I'm asking you to do?
yeah.
Okay. All right, I gotta jump in here because I don't want us to keep going here. What I was trying to get you to see is that you got to look at like minus 2 and 24. If that doesn't work, then it's 2 and minus 24. And then minus 3 and 16 or 3 and minus 16. And that one does work there.
All right.
And the reason that's so important is that's what you're writing over here in parentheses, those two numbers. So you kind of want to have this number fluency where you're like, okay, 3 and 16 are 13 apart. The negative makes them add up to negative 13, which is what we were looking for here. All right, so go ahead and get that down, and then give me the two x values that make this 0.
X equals -3 and x equals 16.
Very good. All right, so here we go. Let's look at number 4 next. This one's kind of already in the right format. We'll go back and do number 3. There's this box. Really like this box here. We have to figure out what goes in the box. Before we can figure out what goes in the box, you have to do something with this middle number here, this +6. Do you remember what to do with this +6?
Gotta divide it by 2 and then square that number.
Square it, yeah. Whatever that number is squared goes into the red box in both places there. What would that be in this problem?
9.
+9. So on the right, this becomes 16 plus 9 or 25. And the directions here, they do say to solve, like we are going to get x values. That is the intent here. What is the best way to get x by itself? How do you undo this square here?
Gotta find the square root.
Square root, perfect. So it's the square root of both sides plus or minus the square root of 25. What is the square root of 25?
5.
Okay. So this is now two equations, really. It's x plus 3 on the left. The square root undoes the square. Squiggly thing undoes that. Plus or minus 5. So you have two equations you have to send. So x plus 3 equal to 5. X plus 3 equal to -5. And then you solve each of these. So this is x equals 2. and x equals -8.
Yeah.
All right, so let's take a look at 3 next. You mentioned a lot of the students in the class really struggling with completing the square. Hopefully you're not one of them now. Hopefully you see the pattern. When we did number 4, the next problem, or the one we just did, there was a number already on that right side. You have to do the same here. You have to move this 9 over. And just as important as that is you have to leave a space. So it's +9, +9, but you're leaving a space. What goes down here in parentheses?
X -2 squared.
Very good. So you cut that number in half, divided by 2, and then what's the number that goes up here? The
4.
box, +4. 9 + 4 is 13. So now this problem is solved exactly the way we did the previous one, except that you can't take the square root of 13. Like it's not a known value. So unfortunately, you just leave it as the square root of 13. Or maybe fortunately, because then you don't have to do any reductions here. All right, what do we do from here to solve?
Gotta add +2 to both sides.
Yeah, and since you don't know the square root of 13, you just leave it sort of in this maybe uncomfortable form where it's not really reduced, but that is what it is. Nothing else that can be done. Any questions on that before we go on to 5 and 6?
No, it's pretty all clear.
That's good. Now 6 is a problem that we have already solved. Do you see that 6
Oh
is
yeah,
one?
it's number 1.
It's number 1. So they're saying now you have to solve it using the quadratic formula. Okay, so if you get a problem like this on the test, you can solve it another way to kind of verify your answer, but you still have to solve it the way that they intend. Like you have to use their method. Thou shall use, quadratic formula here. So do you remember the quadratic formula, or do you have a way to get it down so that you can remember it for tomorrow?
Yeah, I remember it.
All right. Minus b plus or minus the square root of b squared minus 4ac all over 2a. What are the values of a, b, and c?
A is 4, B is -5, and C is -6.
Good. All right, now you've got to substitute these in. And I mentioned it's really probably better to think of all the variables as being in parentheses. So this is negative parentheses -5 plus or minus the square root of -5 squared minus 4 times 4 times -6 all over 2 times 4. I think that I had you use Desmos scientific calculator for this. I'm happy for you to use that today. I don't know what you'll have in the test, but this would be a good time to ask me any questions if you're unsure about how to evaluate any of this. This one does work out nicely, which is why I'd like you to try it first. You do get a nice square root. you do get some nice answers. We already know them from the earlier problem. So do you know, will you be able to use that Desmos Scientific? Do you have a calculator you like? What's kind of your thought process there?
I usually use Desmos.
Okay. I recommend using that today. And we already know the answers. It's just you getting those answers so that you're comfortable with how you would do it tomorrow.
All right.
So go ahead and give that a try, and let me know if you have any questions about how to do that.
Got 5 plus or minus square root of 15.125.
This one should work out nicely.
Okay, what did I do?
Try it one more time. Just the part under the root. Make sure it is a nice number. Do you need some help, or do you got that number?
I think I need some help. I don't know. I don't know what I.
All right. So like you just want to enter it the way you see it in the Desmos. So just the part under the square root, or all of it, but I'm typing it here so I can snip it in, because I really want you to see that there's no magic here. There's no trick. There's just, here it is. Let me snip it. Here we go. So if you enter exactly what's under the root, -5 parentheses squared, -4 parentheses 4 parentheses -6, you will get that nice number there.
Oh.
And that's what I was trying to get you to see, so that you should always do the calculations twice. You should always just really make sure it's the same. Maybe clear the screen and try it again.
Oh, I did the the 2 times 4 with it.
Okay, and that maybe looks reasonable to do, but you got to do it at the end. And so it leads to almost even thinking like, well, why wouldn't you just put all of it in the calculator? Like start with the fraction bar, put the minus parentheses -5 plus. Your calculator can do all of this. It's like the equivalent of like you can light a match, or you can rub 2 rocks together. At some point you're like, all right, let me just get the lighter going here. But this part does reduce nicely. The square root of 121 is 11. But this becomes two things. It becomes 5 plus 11 divided by 8 and 5 minus 11 divided by 8. And like we already have the answers. One is 2, one is negative 3/4. All right, so the good news is that we're going to have another attempt to solve a problem using quadratic formula. Got to get you a little more comfortable with that. It's not impossible. You can absolutely do this. We've already solved number 5 in a previous problem. All right, which is good. That means that you know that it's got solutions. If you look back, it actually wasn't all that nice though. I think it was like 2 plus or minus the square root of 13.
Yeah.
So we know what we're looking for. We know the target. A is 1, B is -4, C is -9. So one of the things that we did to try to make the calculation better is to do the discriminant first, the B squared -4 AC. Will you do that for us, please?
Sure. Okay, so I got 20.
So parentheses -4 squared -4 times 1 times 9. Does that look right to you?
Yeah.
That doesn't look right to me. Why is this? Is this really one we solved earlier? X squared -4x? It is. Okay. This is not right. What is going on here? A is 1. Oh, B is -9. C is -9. That's the problem. Okay. So there's just a small sign here. It's 16 plus 36. 16 plus 36. I think you maybe wrote or put down -36 instead.
Yeah. Oh, wait, no, I did it right. I did -9. It's 20. Says the calculator.
So probably just a sign error. I mean, because it is -9 there.
Yeah. All
All right.
right.
So this is the square root of 52. And a lot of, this is or D is 52. This is where a lot of the errors occur. So the quadratic formula is -b plus or minus the square root of b squared -4ac all over 2a. You now have everything. You know that it's -4 plus or minus the square root of 52 all over 2 times 1. And the question is, well, how do we get it to the answer we already know that is correct? So to proceed here, you negate the number in front, that's 4. Now the square root of 52, you kind of have to come off to the side here and do that factor tree we've talked about. Do you remember which numbers we start with to figure out what goes into 52?
Usually 2.
So always start with 2. Hope it works. This is where if you had that calculator, you quickly, okay, 52 divided by 2, oh, that's 26. Does 2 go into 26? 26 divided by 2, that's 13.
13.
for any pairs, you bring one out. So this becomes 2 square root of 13, all divided by 2 on the bottom.
Yeah.
All right, almost there. You have to divide each of these by the 2. All right, so 2 plus or minus, what happens over here on the right with the 2 squared 13 over 2?
I think because the number in front is not this.
The 2 over the 2.
Yeah.
So it's just like this on the left, where you can put the number over the number. The square root's going to be off to the side. What is 2 divided by 2?
1.
1. So there's your answer. That's what we expected. We already kind of knew what the answer would be because we've solved this problem previously.
Yeah.
So let's look at number 7. All right, using the discriminant, how many solutions are there for the following quadratic equation? All right, so this is just the part that's the b squared minus the 4ac. A is 1, b is 7, c is minus 4, just like in the last problem. Done that over and over again. Be as careful as you can here to first calculate the discriminant, and then we'll talk about what are some of the possibilities.
So I got 65.
Very good. So it's positive 65. So there are 3 possibilities. If the discriminant is greater than 0, that means there are 2 real solutions. If the discriminant is equal to 0, there is 1 real solution. It's called a repeated root. And then the third possibility, which I don't know if not sure if we and I have talked about, but it's 2 complex solutions. These have eyes in them. So it might be good to put that on a note card. Depends on if you think it'll be different than this review here. All right, so we're going to look at 9 first. Then we'll go back to 8, if that's okay.
All right.
All All right, so here's the new problem here. It says given f of x equals x squared, how would g of x shift? Okay. To answer this question, if you were able to graph this, like let's say you had a graphing calculator, Desmos graphing tool, I would tell you to graph this. Is that a possibility for you or not?
Not right now.
No, I mean, do you have that though when you're taking the test?
Yeah.
You do. Oh, good news. Okay, so here's what I'm going to do. I'm going to graph the original. Hopefully you remember what the original looks like here, but I'll snip it in. All right, so here is the original. Notice its vertex is at 0, 0. And then here is the transformed one, which you enter just the way it's written, plus 2. And let's check that. Always good to get a picture. You know, people like to see things. People are visual. What happened to the vertex? Which direction did it move?
Up and to the right.
So you start, excuse me, you start by talking about the right or the left before the up or the down. So how would you describe that? Would you say, how many to the right in this case?
3 to the right and 2 up.
So right 3 or 3 right, and then like you said, up 2 or 2 up. The word is super important. If you don't have the word, they don't know what you mean. All right, new problem here. The number 8 has the other 2 types of shifts that you might see. I probably should have asked you if you knew what it would do beforehand, but if you can graph, I would certainly graph. Any idea what this negative does, though? Do you remember that?
Uh, makes the shape curve down.
Yes, really good. So here we go. I'm going to snip that in here. You can see that it causes the graph to go down. Okay. Now this 5/4, you really have to make a decision about whether this number is greater than 1, it's called A, or if it's less than 1, between 0 and 1. If it's greater than 1, it's called a stretch. If it's between 0 and 1, it's either called a compress, or maybe your teacher like shrink, something like that. So you have to decide though, is this number greater than 1? Just the part without the negative. Is the 5/4 bigger than 1, or is it between 0 and 1?
It's greater than 1.
It is. So this is a stretch. So you would say stretch by a factor of 5/4. And then the negative means to flip or reflect, depending on what you've seen in class, over the x-axis. They're typically looking for that word. It's kind of like the fill in the blank. You want to make sure that you know kind of what to put there, because while what you said was correct, you know, it goes down, that may not be what they're looking for.
All right.
Okay, next question, next page. All right, probably not gonna get through all this. So do you want to pick 1 or 2 for us to do next? Maybe ones that 10, 11, 12. I don't think we can get through all of them. Probably get through 2.
Let's do 12.
Okay. We will do 12. All right. So just when you thought you got away from completing the square, guess what it says here? says to sketch the graph by completing the square. All right, so to do that here, you take that original f of x, x squared minus 2x minus 8, you set it equal to 0. And then from here, you add 8 to both sides. X squared minus 2x, leave a space, equals 8. Can you tell me, after you kind of work this out down here, what goes back in this red box?
Sure. One.
Plus 1, plus 1. So in parentheses, I hope you wrote x minus 1 squared equals 9.
Yeah.
And then what's different about this problem is that you subtract 9 from both sides. So you bring it back here, x minus 1 squared minus 9. That's your function. All right, so the next part here, there's like a lot to do. It's might as well be like 3 or 4 problems. It's asking for the vertex form and the factored form. You just found the vertex form. The factored form comes from you setting the function equal to 0 and finding two numbers that multiply to -8, but then add to -2.
Two and -4.
Yes. So this becomes x plus 2, x minus 4 equals 0. Really good. And the idea is that all of these are equivalent. They all equal the same thing if you make some adjustments.
All right.
All right, so graphing is next. Put that on the right here. It says 5 good points. One of your points should be the vertex. So you already have that. The vertex comes from the vertex form. Do you remember the vertex from this?
In parentheses, x minus 1 squared minus 9.
So that is the vertex form, but just the vertex is an ordered pair. All right, so that it ends up being 1 and -9. 1 and -9, which we don't really have room for here. So you can either extend the graph, 1, 2, 3, 4, 5, 6, 7, 8. I'd probably extend the graph instead of going by 2, probably just extend it. The other points that you might use could be the x-intercepts. Those come from the factored form. Can you tell me what those would be from this equation here?
+2 and -4.
You're setting the equal to 0.
So -2 and +4.
Yes, so there's another couple of points. Okay, so it says 5. We got 2. So the next thing to do is to make a table potentially and fill in some points. So x and y, usually it's around the vertex, like 0 and 2. And you have to put these values in for x. So just to be clear here, we're putting like 0 back into either the original function or the vertex form or the vertex form. There's almost too many options. But when you put 0 in, you get -8. And by symmetry, it ends up being the same as 2. And then that's kind of sufficient for the graph there. So let me really quickly go through this. So we've already talked about the vertex 1 minus 9. It's a minimum because it's down here at the bottom. The axis of symmetry comes from the vertex. And we've actually already done the x-intercepts. That's the -2, 0, and then the 4, 0. And then we just happen to land the x-intercept, y-intercept as well. Fortunately, we don't have enough time to talk about these. Short of me just giving them to you, I don't know if that would help, but we've done this in other lessons, so maybe take a look at those and see if you can find something, or maybe you already know the answers. But we do unfortunately have to stop here for today.